Brilliant. Welcome to our penultimate panel session. If you're joining us now, big welcome to everybody. Validate and verify a new opportunity, no pressure, gentlemen. There are many opportunities to make products last longer by remanufacturing them, but we also need to ensure that we consider those hidden challenges of ensuring that those remanufactured products are also fit for purpose. This has to be done through greater focus on verification and validation as well as manufacturing processes themselves. We have 4 experts who are going to share their knowledge and hopefully share your best practice as well. So I'd like to give a nice big introduction to Andy Imrie, who'll be first up. He's Principal Engineering Consultant for Innovation, Business Development and Tech Startups for Lloyd's Register. Welcome, Andy. We'll see you up here shortly. Michael, I'm now spinning around this way, aren't I? Yeah, you've done this to confuse me. Michael Forbes is General Manager Refurbishment Engineering for Renewable Parts Limited, a company that is supply chain and refurbishment specialist in the wind energy industry, applying the latest techniques to restore unserviceable parts to their original as new condition. Looking forward to hearing from you. Tommaso, I'm looking at you straight away, and I am going to try and pronounce his surname, everybody, badly. Migliolo. No, as you can see, I got it completely wrong. He is Business Development Manager for Williams Advanced Engineering with a keen interest, as we've heard and learned, in engineering and sustainability. Tommaso has been involved in a number of electrification programs supporting the decarbonisation of multiple platforms. Looking forward to hearing from you. And our last speaker, I've got to spin myself back round, is Ian Minton. Ian is Technology Capability Director for BAE Systems. Ian chairs the Industrial Liaison Board of Burnley College and is an active STEM ambassador. Those are our 4 panellists. Please make sure we get the phones out, as I would like you to answer a poll question that we've got coming up now. Hopefully I won't see my face. Looking to the future, everybody, what best describes your organisation's opinion on remanufacture as a viable part of your business model? You'll see, not in our current strategy, hopefully we won't get many of those, but we do want to have honest polling here. We expect to consider it in the next couple of years. We're currently considering this very question. We have already some remanufacture processes already planned, or we are actively operating remanufacture within our business. So please make sure you answer that poll for us, which we can discuss at the end of the panellists. Without further ado, please give a big round of applause wherever you are in the venue to our first speaker. It's over to you, Andy Imrie.
So remanufacturing is quite a new subject. It's been around from an engineering standpoint for around about 30 years. In a way, it's very similar to another technology which is very close to my heart, which is additive manufacturing. Additive manufacturing has also been around for many, many years. It's been used in nature for thousands of years. If we think of things like wasps and other animals building their nests, they use 3D printing. And 3D printing additive manufacturing is also a big part of remanufacturing. But one of the other things that I spend a lot of my day-to-day job doing is working with organisations and really dealing with really the boring and uninteresting things, which is dealing around the codes and standards, looking at what requirements and regulations are needed for people to get parts into the marketplace and scale their businesses. Now, additive for me about 7 years ago was a real challenge because I work for an organisation that's been around for, 270 years, and every code or standard that you open up basically is based around the work that Lloyd's Register did originally around ships. And they basically helped to write the very first standard for ships, and every standard and code and regulation you look at is built around that. Now, the problem we had with additive manufacturing is very similar to remanufacturing. If you pick up any code or standard today, you cannot turn to anywhere in that code or standard that says anything about remanufacturing. It will tell you how to build the part, it will give you acceptance criteria, but it very rarely gives you how to remanufacture something. Now, remanufacturing is a great way of saving money for organisations. It saves money for consumers. It's a fantastic, and what's sort of referred to probably as, rather than a cradle to grave, is more of a cradle to cradle innovation. Design by its very nature was very linear. we looked at, from the point of view, we had an idea, we created a concept, we designed it, we manufactured it, we sold it, and traditionally we didn't really care where it ended up. It was very much a linear thing, a straight thing. Not dissimilar to the stage in some respects, which is now circular. We're very much into this circular manufacturing. For me, one of the most difficult things is trying to explain to our clients how remanufacturing, how the circular economy and sustainability is going to affect their business. Because before, they didn't have to think about the parts and components that they made once they came to the end of their lives. Yes, they may put some traceability in there, they may recall some of the parts or reuse them, but only to get them recycled by third parties. Remanufacturing and automotive and people like Caterpillar and Bosch and people like that have been doing this for a while, and they have a very good return system in place. But when we start thinking about quality assurance and how we control the remanufacturing process, it's far more complicated than a traditional quality system or manufacturing system. We have to think about the first thing is how do we get the parts back into the facility? And then once we get the parts back in the facility, how do we assess those parts that come back in? The first thing we need to be able to do is to determine which parts we can remanufacture and which ones we can't. And in traditional manufacturing, we know what's happened to every single part and that component. It's been procured through a control system, it's got standards, it's been checked in through goods inwards with systems, procedures and people. And then right at the very end, it's been inspected and dispatched out for its final use. The part that's come in, we know nothing about in many cases. We don't know if it's failed through misuse, it's been damaged. We don't know anything that's happened to it. So we need to have testing in place, which is very different to the traditional testing we have for a normal part. Is it water damaged? Has it been, been through fire? Is it contaminated? Even with COVID, how do we look, how do we decontaminate something which, potentially wasn't ever designed to be decontaminated? The other thing as well is taking the item apart. Most of the items that we buy these days are designed as single use, and they're certainly not designed for, in fact in most cases, for those of us who've worked on cars over the years and other things, they're certainly not designed to be worked on. They're designed and made to be built in factories. They're not designed to be reverse engineered and taken apart. And certainly in lots of cases, once you start taking them apart, they're designed with inbuilt obsolescence. They're designed to have a very, very short life because, every 2 years we want you to buy a new one. The perfect thing is to have a 12-month warranty and a 400-day, working life, because after that we have to buy a new one. Now obviously as a planet we can't carry on like that, because all we're doing is we're just creating single-use products. And as we can see, on the news, and the whole reason why we're here with COP26 is around that. So from a manufacturer's point of view, what do they need to do? And it really falls back to the presentation we had earlier, which was around design. I was brought up for design for manufacture, possibly design for inspection in service, design for maintenance, but now we need to design for a complete life cycle. We have to think about, do we want this to be, how easy do we want it that the item itself can be taken apart and refurbished? If we make it too easy, then other people will start, basically repairing our parts and we won't get that value in. If we make it too difficult, then we're providing ourselves with problems. We then start looking at, the main components that we want to save. We've got to come up with methods of determining whether they're acceptable or not and whether they're safe to use. Originally, they will have been designed, in most cases, for single cycles. You have maybe a part that's subject to fatigue, might be designed for 500,000 cycles. You start taking that round 3 or 4 times more, you're not normally designing it in for 3 or 4 times more use, so you don't know whether that part's going to be fit for use. And then we start looking at the other things that can happen within a facility. Who was going to do this remanufacturing? Who's going to take that part, the thing apart? Are we going to subcontract this so that we're not moving parts to one central location? How do we control those operations? How do we make sure that everything's done consistently? There's a lot of things there that need to be considered, and I've just noticed my time's gone down to 0, so I will pass it over to the next presenter. Thank you.
Thanks, Andy. Thank you very much. Thank you. That was a great end to that session. Before I introduce our next speaker, please get those poll results in. Thank you to those of you who've already contributed, some very interesting answers already on there, so just make sure that you've got those for our next session. Ladies and gentlemen, without further ado, big hand please for Michael Forbes.
Hi everyone. I'm hoping for the next 6 minutes or so I'll be able to compete with a robotic dog that's walking around. So I'm Michael Forbes. I'm the General Manager of Refurbishment Engineering at Renewable Parts. Renewable Parts is a supply chain management business operating in the wind industry, mainly in the UK. We do export. We mainly work onshore turbines, but we do supply to offshore sites as well. Our head office is actually only maybe 100 metres in the building right next to us here. So if you take your headphones off and listen carefully, you can hear the colourful language of our warehouse team. So I've been with the business for around about 4 years now, and I joined the business to help start up and grow the engineering capability. The business was founded 10 years ago. This is our 10th birthday. It was founded by a man called Ewan Anderson, who had been a wind turbine technician. He started to repair wind turbine parts. As the business grew, it became apparent he had to move further down this way to the central belt. So he moved the business to Renfrew here from Lochgilphead on the west coast of Scotland. The business has grown very steadily over the last few years. But like I say, 4 years ago we opened the Innovation Centre in Lochgilphead where we recirculate wind turbine parts. At that point we dropped the word repair from the process altogether. We feel it devalues what we do. So everything we do is fully refurbished. We match the manufacturer's warranty for all the products, and we feel that's the only way to do this at scale. So, creating a circular economy in the wind industry. So, the way our process works is we recirculate wind turbine components by selling refurbished components off the shelf. So these components are coming through our production facility in Lochgilphead. They're being refurbished, they're going on the shelf. Our customers are buying them from stock, and they're returning defective units. Now this is maybe slightly similar to a car alternator where you maybe buy a reconditioned unit and return the old one in return for a rebate. We tried a few means of getting these parts back. We found that putting a value on the defective component was causing complications because we were dealing with maybe a procurement department who then wouldn't know what their price was going to be until we got the old one back. So we decided to take the risk, and the way this works now is we accept the old part back regardless of condition as long as something's sent to us. So we've taken into account what we think is the worst case scenario on condition. So we supply a number of different parts. We do mechanical parts, hydraulic, electrical, electronic. A lot of these parts are subbed out to third parties. These third parties are trusted partners of ours. We audit them regularly. We make sure what they do falls in line with what we would expect. And the way that works is we see it as a pyramid with renewable parts at the top, with a whole range of businesses supplying specialist services to us. This then allows us to supply into the wind industry. It works for the suppliers because they don't have another route into the wind industry. It works for us because it improves our offering, and it works for our customers because they then have more choice from one point of contact if they want to just buy refurbished goods. The circular economy in the wind industry, the picture you see here, this is pretty typical of when I started 3-4 years ago. Lots of wind farm sites. I'm not going to name and shame which particular site that is, but it was commonplace to see skips full of goods that are now the parts that we refurbish quite regularly. On the other side of that slide you see a complete set of gears. We've got these kind of gears at our stand over in the corner there. So we are now recirculating parts at scale. We're able to report back to our customers about what kind of waste and scrap saving they're making each month by customer, by component, or both. You can see these kind of parts over at the stand. To put things into context, we also have a brake caliper for an offshore turbine over at our stand there. That brake caliper, I think assembled, weighs around about 160 kilograms. There's 8 of those in an offshore turbine. There's 1,000 of that type of turbine in the UK. So we reckon that part alone, if it's swapped out once in its lifetime, is going to account for 1.3 million kilos of scrap waste within the next 10 or so years, which equates to around about, well, over 2,000 tonnes of carbon emissions in production of that equivalent steel. So the biggest challenge for us was setting up reverse logistics. So reverse logistics was really quite difficult. I was glad Andy touched on it. Reverse logistics was about us making it as easy as possible for goods to be returned. Sometimes we actually physically build wooden boxes around the product so there's no plastic packaging to be used. The product goes out, the old one comes back in the same box. We've made it as simple as possible so the site technicians find the process easy. In most cases, the boxes we supply the goods in, or the crates or whatever we sell, are easily stackable, they're easy to store, and they keep the product safe for getting returned to us. The main thing really is the validation of the refurb, though. I think by coincidence we actually had some correspondence with Andy about how we validate our repairs. There isn't really an industry standard for refurbished or recirculated or remanufactured components, so we're speaking with Lloyds about how do we standardise our process and say if this is how we do the job, then we're happy to guarantee that work. Like I say, we match the warranty of new, so a lot of work was into our R&D process in the first place to make sure that's up to scratch and that our customers are happy with what they're going to get. We need our customers to compare the refurbished or remanufactured part directly with new when they're buying these parts. I see I've got 20 seconds left. Is there anything else you'd like me to do? So we work a lot with various different departments of the University of Strathclyde. Sir Jim this morning touched on the NTTP fund. We've got 3 graduates from that fund at the moment through NMIS, so we overlap with various different departments, and we certainly get our money's worth out of Strathclyde University's different departments. Thank you.
If you can hear that beeping, it's not me actually giving any of our speakers the clock, it's actually the cooker in the food truck. I was trying to work out what it was, and I feel like it was me telling people to stop speaking because they stop very quickly. It's definitely the food truck, not me. Thank you so much, Michael. Next up, without further ado, here to come and talk to us, please welcome Tommaso onto stage.
Production. So, industries associated with electrification in the next few years are going to face a significant challenge in being able to procure the required materials to build battery packs. Based on traditional economic and manufacturing approaches, this is a scenario which over the next 5 to 10 years is going to have significant challenges and impacts on decarbonisation goals across multiple different industries. Over the last 10 years, there have been multiple approaches and business models that have been developed as to how we can actually approach this challenge in a more sustainable and environmentally friendly manner. And I'd like to touch on a couple of those here today. The first of those business models, or frameworks, is the donut economy. This is a concept that was developed by Kate Raworth, and it really provides a macroeconomic framework as to how we can live and develop in a more sustainable manner. The outside of the donut refers to the planetary boundaries in which we live. So in other words, how many materials and resources can the planet provide to us in a sustainable manner? The inner ring depicts the societal boundary. In other words, where do we need to be to live an equitable and sustainable lifestyle in a societal sense? And this was something that was very much derived from the Sustainable Development Goals set in 2015. The zone between these two boundaries is really where we need to be to live in a sustainable and equitable world. The second concept that I'd like to talk about is the concept of circular economy. And this is something that's been very much brought to the fore through the Ellen MacArthur Foundation. One of the main aims of the circular economy is really to extract the most amount of value out of any given product or resource. And this is done through challenging the traditional take, make, use and waste approach into a much more, has been referred to in earlier presentations, as the cradle-to-cradle approach. So where does remanufacturing actually sit within all of this? So as you can see on the right-hand side, there's the restore area. Remanufacturing really is one of the strategies that's being used to maximize the value of any given product or component to really extend its lifespan. And as indicated by the Ellen MacArthur Foundation, there are 2 different types of nutrients that are required to develop a certain product: your biological nutrients and your technical nutrients. The circular economy aims to really maximize the value of the technical nutrients while restoring and regenerating the biological nutrients. So technical nutrients, typically, you could associate with materials such as aluminium and steel. However, sticking on the theme of electrification, you can see materials such as lithium and cobalt being central to enabling that. Remanufacturing really aims to capture a huge amount of value out of a product throughout its lifespan. In the automotive industry, there are many different ways in which manufacturers are actually approaching this challenge. And arguably one of the most innovative and interesting approaches that's being taken is around modularity and exchangeable modules within a vehicle's battery. The idea being that once you use the battery and once it starts to naturally degrade through cycle charging and calendar aging, you can then simply exchange the module and refresh the battery back to its original condition. And in order to achieve this, it was mentioned earlier in the design presentations, you really need to have a very much a holistic approach in terms of design, in terms of understanding the different life cycles that product will actually end up going through. So trying to plan in advance as to how the product will behave over its life cycle. A really interesting application for those output modules is actually around stationary energy storage. And you can use these to provide huge amounts of value, not only in developed communities, but when you're looking at developing communities and developing nations, actually being able to provide a means to capture renewable energy and be able to use it over a duration of a day, it brings a huge amount of value at a fraction of the environmental cost, but also economical cost, and thereby enabling that kind of technology for those developing countries. It was touched on in earlier presentations, and one of the main challenges actually facing the remanufacture of components is returning goods. And it was touched on by the presentation, I can't remember the gentleman's name unfortunately, from Rolls-Royce, but understanding how business models can actually impact the return of goods to manufacture. And this is something which there are many innovative models, there's no one right model. However, one that stands out to me is actually the Apple iPhone repair scheme or upgrade scheme, whereby for a monthly fee you can pay a set fee. Apple then sends you an iPhone out at the end of the year, and you then have to return the iPhone as part of that agreement. And in doing so, Apple can actually then remanufacture that phone into the same product and sell it on again to developing countries, enabling access to that type of technology, or they can then choose to reuse, recycle into new products and new components. So what's really clear to see is that there's a huge amount of value that can be recaptured throughout the life cycle of a product. But what's really very key and necessary to achieve is actually having that collaborative approach, and that really needs to enable a whole systems thinking development behind that also. And it's clear to see that by achieving this, we can actually then meet and resolve some of the biggest interconnected challenges that we're facing today. Thank you.
Thank you, Tommaso. Thank you. Please do not forget, no question today is a wrong question. It's a discussion, it's a debate, so make sure that you ask the question in the app, and if you don't want to open the app because you're enjoying the conversation, I'll come along with the microphone. Now, last but not least, please give a big warm welcome from BAE Systems. It's over to you, Ian Minton. Thank you.
Thank you. So, good afternoon, everyone. I'm going to try and take you through a bit of a story about aerospace and how some of the topics we've been talking about today mean to this sector and what that challenges are. So, I'm going to talk about aerospace in general, even though I'm from BAE Systems. So pre-COVID, that time when we all remember and rejoice, there was a lot of predictions about air travel. A lot of the predictions that the likes of Airbus and Boeing were talking about was the civil fleet was going to double. So the number of aircraft flying by 2038 is double the number of aircraft flying in 2018. That was a prediction. We all know how we felt now about wanting to go and visit people. So at the moment it looks as though that prediction, well, numbers might be slightly wrong, but it's not so far off. So we're going to have to make those aircraft. The other aspect we've got to do is understand our ecological footprint. There's been a lot in the press, a lot of people talking about how aerospace footprint. And a lot of people are talking about the fuels we use, sustainable fuels, hydrogen, all going on about that, because the predominant emissions from aerospace is in flight. What we're not talking about are all the things in the manufacture before then. And actually, if you ignore the emissions from the flight, 63% of the emissions of the aircraft in the manufacture come from getting the raw materials out of the ground and processing them into a form that then you can make the components from. So it's clear we need to work on that aspect, which brings us back to the recycling, reusability type question. But there's a barrier in aerospace we're going to have to look at that I need to set you some context about. Aerospace is all about predictability. We're safe because we know that in engineering that aircraft, we know how it's going to respond, when it's going to fail. That relies on us knowing the material, how strong it is, and knowing that aircraft after aircraft, batch after batch, if we do this to it, it will always react in the same way, which means I need to know what goes into my aircraft. So just hold that thought. So in terms of what we're doing in BAE Systems and other areas in aerospace, let me take you through the life cycle, from concept through assessment, development, manufacturing, in service, and what previously was usually a disposal phase, but now is more and more a recycling phase. So in terms of the whole concept area, we use energy. So one of the things we've done is installed solar panels. So our Samlesbury site has over 9,000 solar panels that since 2015 have been generating over a third of the energy for that site through that renewable source. We're looking in research into manufacturing. We've got our factory of the future. That's looking at how do we reduce materials, both from how do we reduce the tooling we need, by looking at how robots can help us assemble aircraft. That means we don't need tooling as much. That means we can reduce that material. But also the likes of 3D printing, Andy talked to it earlier, understanding how do we make the material less and improve what's called the buy to fly ratio, making sure that we have less and less waste. In service, we're working on, in a similar vein to what Steve talked about earlier from Rolls-Royce, the hangar of the future. What does the digital help us in terms of making the product more maintainable? How does it help it stop being maintained because it's more reliable, or we can act it beforehand? And another key part in that is synthetic training. Last year we delivered over 9,000 events with the RAF that saved 13,000 aircraft flights for them. That's 75 million litres of fuel and 185 million tonnes of CO2 through the pilots sitting in a room and doing it on a computer rather than flying a jet. Now that is an innovative way of using digital to reduce the emissions that we see at the moment. And it's a key part of the RAS philosophy going forward as to how they can involve that more. But then we end up back at the recycling question. Now, if you imagine an aircraft, it will fly for 10, 20, 30 years. During that time, it will see lots of events. Andy alluded to it earlier. It will have contamination. It will see fuel, oil, hydraulic, maybe a fire, maybe damaged. So who knows what comes off that? Finnair recently produced a study that they had recycled an A319 aircraft and recycled or reused 99.2% of the aircraft. And when they broke down what they'd done with that, 50% of that was material they reused. 4% was research, 35% were parts, as Steve said, that they used again because they weren't ready for use, and 8% was sold as energy. So if we come onto that recycled, and back to the bit I talked about earlier in terms of we need to understand the material state. We're quite confident now in terms of the industry. How do we reuse metals? How do we recycle metals? How can I tell which type of metal it is off an aircraft? And therefore, how can I recycle it? Composites, however, that's a lot more difficult. And the A319 aircraft was not a high composite value in terms of aircraft. So fundamentally, for us in aerospace, for us to reuse the materials we are using on our airframes, we need to understand how do we get a material that after recycling we know how it will react, we know it when it will fail, and we can be sure on aircraft 1, aircraft 100, aircraft 1000 that it's the same material. And at the moment, recycling whatever comes to hand makes that very difficult. So just to summarise, one of the challenges that aerospace has, and one of the areas it needs help from other sectors, is the material from this doubling of the fleet as it comes to recycling is going to be a large food stock for the sorts of things that Michael talked about and Tom in terms of reusing those materials in other sectors until we solve that challenge of how do we know the material and how it will react for us. Thank you.
Lovely. Thank you, Ian. Big questions to be asked there. Big questions to be asked. Can we have a look at the poll? Let's see the results. Thank you to all of you who contributed to this one. You who've had your apps open, I have to say that correctly, will have had a look, but I'll give 2 minutes 20 seconds for you gentlemen. Very positive, 41.4%, but Michael, 24.1%, there's a big cube of purple there that's saying not in our current strategy. What do you say to those people who've polled that result?
I think it's a tricky one to comment on because everybody has a different definition of remanufacture. Sure. So we've had 2 or 3 conversations today alone, and we've had a fairly large internal argument in the business just in the last few days about the definition of remanufacture. And for us, we're going to be starting to use the term recirculate rather than remanufacture when dealing with customers, because some people consider remanufacture to be a design improvement. For most folk, I would say remanufacture is if you refurbish something but give the full OEM warranty on it when you're finished. So I'm not surprised that there's quite a large portion would say that they're already remanufacturing. I think the fairly hefty chunk that don't have any plans at all at the moment, I wouldn't be surprised if that changed over the next couple of years, and it's just not been picked up on yet.
Quite often it can be in the conversation around language. Andy, I can barely see you because I haven't got my glasses on over here. What are your comments about this and what Michael's saying about that word remanufacture as well?
I think the important thing is to look at the product mix, and if you consider something which we really think of as being exceptionally green as wind turbines, within the next 5 years, if I get the figure right, I think there's going to be 50,000 turbine blades that are going to be scrapped, and we have absolutely nothing that we can do with them other than potentially grind them up and use them in roads or bury them. So, you know, when we start thinking about remanufacturing the whole design thing, yeah, if you're making wind turbine blades at the moment, you're probably going to sit in that region of, we're not considering it because we don't know how to do it, because we can't, once it's glued together, we can't take it apart. So, yeah.
The challenge that you were saying around this is an aerospace, you quite possibly could have polled that.
I think so, and I think one of the things perhaps people should consider was what I was alluding to at the end of our point about how do you use it in other sectors? Maybe part of the people who it's not in your current strategy is thinking about how do I use it on my product, and maybe the thought needs to be which industries do I tie up with that perhaps could use what I'm using and help them, because if we can reduce all the material extraction from the world, whether it's in aerospace, automotive, food and textiles, whatever, it's going to help in one way or another.
Tommaso, I can see you nodding. This sounds like a beautiful idea, but we're running out of time as well. How do we expedite this?
So this is something that Williams is actually very fortunate in terms of our involvement in motorsport. So a lot of R&D that we actually do in-house is based on motorsport activities, whether that be through Formula One or Formula E, Extreme E, and so on. So in terms of having a test bed to develop these types of technologies and understanding the technology and how it degrades over time really is a key aspect of the work that we're doing. And keeping it specifically on an electrification theme, understanding how a battery degrades over time is really quite critical, because depending on the chemistry, depending on the use case of that battery, it really depends on what it can then be used. So taking the example of what Steve was saying earlier about going from industry to industry, absolutely. So when you look at aerospace, the batteries that are required in that are incredibly high tech and require some very innovative technology. But then as they degrade, absolutely the capacity can be used in products, in services that don't quite need that same level of technology. So by being able to take a bit of a holistic approach, understanding the different life cycles of the product and where that product could be used right at the very beginning of the design phase, you can then start to design with modularity in mind, with disassembly in mind, and that really all enables the remanufacturing of a product, but then also looking at the different products and service streams that you could have in the future.
I think there's already some examples underway that we don't talk about in the remanufacturing sense, but they're in the sense that. So aerospace, in terms of buying composite material, has a very high specification that it wants the material to meet. But by virtue of that high specification, what the manufacturers do is they produce material and then they select the bits that are in the right specification and sell that to aerospace. The automotive sector loves it because what they say is all that stuff they can't sell to aerospace, they've no one else to sell it to, but we get it cheap and it's great for what we need. It just does the job. And that, in a sense, is what we're talking about in terms of using that material and then making it for various uses rather than the one it was aimed for only.
I think the point about the waste coming from aerospace as well, a lot of that waste is unsuitable for reuse in aerospace because it's there's a safety factor or it's load bearing, whereas there are applications for us where we're possibly working on parts that you don't have to meet these criteria, so it's stuff that's off use to us and can be recirculated in another industry.
So you, as the sector in the wind industry, should be going out and telling all the other sectors on how this is all going to work, Michael, yeah?
Yeah, I think our priority at the moment is hoovering up all the parts that are currently being disposed of. So at the moment, the OEMs are being very, obstructive. So if we get a part in, the ideal scenario for us is if we get a part in, we get an exploded diagram, a parts list, we order the parts and we repair it or refurbish it and sell it. 9 times out of 10, there are no diagrams available, or they are OEM protected, or we're not allowed to buy the parts, so we have to then reverse engineer that part, look at getting a UK based manufacturer to make the part for us so that we can do that job. And I would say over half of our R&D time is spent on trying to get round OEM obstacles.
And I just want to bring in, because that is one of the questions I've got here, is, will there always be limitations on what can safely be remanufactured, or is it just a matter of time, effort and ingenuity?
I think if you throw enough money and time at anything, then pretty much anything is possible.
Time we don't have a lot of.
Precisely, but I think in a way it's not always a technical solution that's required. I think one of the things that really motivates people into action is basically legislation. It's quite a boring thing, but if the government's put down and they say, within 3 years you can't use this material, or within 5 years you've got to be able to recycle this, then that's set in stone. You have to do it. And most organisations work on what I call nice to haves and need to haves. So, when things are going well, looking at the oil and gas is a great example of that. When the oil price was $140 a barrel, all the nice to haves were getting done. But when it was down at $20 a barrel, they're coming to us and they're saying, they're coming to us as an inspection organisation and saying, what do we, how much do we need to do, and where can we, do we really need to do all this other stuff? Because that's costing us. That's coming off our bottom line. So it's not that they're not wanting to make it less safe. They just want to do the minimum they can. But I think without legislation, and also the other thing which was mentioned in previous presentations is culture as well. You need to change people's perception. Everybody wants the next new shiny thing. Everybody wants that next thing. And, we're reaching a point where we may not be able to have that nice new shiny thing. So,
Tommaso?
I think it's really interesting that you say that. So public perception is definitely one of the big challenges in terms of remanufacturing and perception around quality of a product. However, we were talking about definitions earlier, and the definition, the way that I see it in terms of remanufacturing, is being able to manufacture the same product which still hits the same levels of specification and standards as the original product. And so I think it's almost a question about education in terms of public understanding around what actually is a remanufactured product, and then having the standards that actually support that, and then the government and legislation actually get behind that and understanding of what remanufacturing actually constitutes.
It's usually a couple of things, isn't it? One of them is very much, I want to know that what I've got is good for you, so it's as new. The other thing interesting is what it looks like. So again, from aerospace, we had an interesting phenomenon probably about 20 years ago now, when the regional jet entered into operation. So you got the likes of Embraer and Bombardier issuing aircraft with jets on, 50-seater jets, and immediately the customer perception was that was newer than the one next to it because that was propellers. Now actually they didn't know the life of the aircraft. but they thought jets was newer than propellers. When we look at some of the concepts we've got going forwards in aerospace and how are we going to reduce the emissions and that, propellers is the way for some of the modes of transport that we're going to go. So we've got to change that customer's perception that jets is new and better, and go back to, well, actually, propellers could be better for this type of flight, and it's changing that understanding that people have.
Who's responsible for the change? It's the chicken and the egg question, and I know that we haven't got a huge amount of time to answer that, so I am putting you all on the spot. And I'm looking at you, Michael.
So we've been in the fortunate position that many of our customers are utilities companies or big service companies in the wind industry, and for the last don't know how many years they've been shouting about the green credentials. Now the spotlight is shining on all these companies to see how they perform, so the pressure is on for them to start buying refurbished or recirculated goods in order to green their supply chain. And it's worked to our advantage because there's always going to be a compromise when you buy a refurbished good, and it might be that it's only cosmetic, it might be just the finish isn't quite the same as the original, and 3-4 years ago these parts weren't being considered by these companies, but in some cases we have certain parts that we're selling for more than the new value, because we've got customers who've committed to buying or cutting the carbon footprint by a certain amount.
It's defining the value, the customer value proposition.
But it is interesting. I go with Andy that legislation goes a long way to making things happen, but shareholders goes a long way as well.
So
there's a lot of people in the shareholders who are saying to certainly big companies, the investment funds are saying, we want to be backing sustainable companies, you are not, therefore we're not investing in your company, we're going to put it elsewhere. And both of those together are starting people to move. It's probably for the wrong reasons, but it's starting the movement in the right direction. So we then need to just accelerate that and broaden that out, I think.
And we're seeing that as an organisation in that we're being asked to carry out more environmental audits, green bonds, and also to validate the companies aren't this great phase of greenwashing, that they're actually doing what they're saying they're doing and actually validating it. So you're seeing companies that are looking at acquisitions and they're saying, well, this is saying that it's a green company and does X, Y, and Z. Can you go in and validate that they're actually doing that? Because, and as you say, a lot of investors are looking that they don't want to be seen to be investing into what they class as what the dirty industries. They want to be in this nice green, warm, fluffy, perfect investment. So it appeals to more shareholder value as well.
Yeah, there's going to be, and hopefully events like this, what's happening just up the road, is going to make a big impact. Gentlemen, exactly. I am so sorry that I'm sitting down completely relaxed thinking we can talk about this all day. Ladies and gentlemen, please give it up for your 4 experts, Andy, Michael, Tommaso and Ian. Thank you all. Again, none of you are disappearing off quickly, I don't think. I'm holding you to this. If anybody has any questions for our speakers, they are here, and we're in a great space, so you can ask questions. You're over exhibiting in the corner. So please make sure any questions, any discussions you want, keep those conversations happening. We have a short break. We'll be back for the closing panel and closing.